So hello and welcome to this session here on using SAP HANA Cloud Vector Engine to build advanced solutions on AWS. What will be covered today? Well, in this session you will learn all about vectors and vector embeddings, what they are, how you can efficiently generate them with Amazon Bedrock, and how you can store them in SAP HANA Cloud. We will walk you through an architecture, step by step, to explain how the different components fit together. And you will be able to use that architecture as a blueprint to build your own advanced solutions. My name is Markus Weierhäuser, and I'm a solutions architect at AWS. And today I'm joined by my colleague Abraham, as well as by Matthias, who's leading the HANA Cloud multi-model team at SAP. So let's get started and look at two of the prominent use cases for vectors and vector embeddings. First, it's semantic search. Semantic search is a key use case, and we all know when we search for something on the web or do some online shopping or listen to music, we often look for something very specific. Like when I want to buy a book, for example, I enter the title of the book, I find that book, and I can order the book. Now, for that use case, a keyword-based search or rule-based search works very well. But I don't know about you, I like to read a lot. Non-fictional books, but also fictional books. And unfortunately, all of my favorite books from my favorite author I already have read. So now I'm looking for similar books or similar authors, and for that, a keyword-based search doesn't work that well. And vectors and vector embeddings help in that situation because they capture the semantics and allow us to search for similar items. Another popular use case is generative AI. And in today's tech world, Gen AI is one of the dominating topics, if not the dominant topic. In fact, unlike many other IT innovations, Gen AI resonates with business stakeholders just as well. And vector embeddings play a crucial role in every Gen AI technology. It's that critical that without vectors, Gen AI as we know it today would not even exist. It's that simple. So let's break that down a little bit and look at the different components that are required to build an advanced solution. And it all starts with data. It's your data. And that can be structured data, that can be unstructured data, it can be data stored in a relational database or in a data lake, for example. And it's not only text or documents, it can be binary data as well. Like, for example, pictures from your product catalog or audio files from your recording, from your last call center recording, for example. And once you have identified your data set, you can then use a foundation model, a special foundation model like an embedding model to generate vectors and vector embeddings for your data. Right? And once you have those embeddings, you can store them in a vector store, like, for example, SAP HANA Cloud. And we walk you through that approach in detail later on in the presentation. Now, we have already talked a lot about vectors and vector embeddings, but what are those actually? Right? So let's have a look. Simply put, vector embeddings are numerical representations of entities. That could be text or images or audio files, for example. And each vector is just a very long set of numbers, usually hundreds of numbers comprising that vector. Right? And the main purpose of using those vector embeddings is to capture the semantic similarities and relationship between entities, and also features and nuances of text. For example, in that example here, when we look at New York as a word, that would translate to a vector, and Paris, as another word, would translate to a different vector. Right? Now, those vectors can be clustered, and those clustered we call vector embedding spaces. And by looking at this example, for us, it's obvious that those clusters that we see here is city cluster on one hand and animals cluster on the other hand. But that doesn't necessarily have to be the case, because Paris could also be a first name rather than a city. So it's really the context that decides where to put that vector in that vector embedding space. So context is really important for everything we're doing in terms of searching or Gen AI. And the more precise we have defined the context, the better our search results are, or the more specific the responses are that we're getting from the large language models here. Right? So with that, let's look at a more specific example here and dive a little bit deeper into those vector embedding spaces. Right? And vector embedding spaces are widely used in personalization services like Amazon Music to capture the semantic relationships between the different items. And those items, in terms of music, could be, for example, songs or artists, but also metadata like lyrics, for example, or album art. And not only that, also the way you interact with that application is also something that feeds into generated that vector embedding space here. Right? So in that example that you see here, you see a lot of different dots with different colors, and those colors represent the different genres of that music library. So you see pop music has a color, rock music, classical music, or jazz music, for example. And each dot in that example represents a playlist. And the playlists that are semantically similar are closer together on that chart here, and the ones that are different are wider apart, basically. And that allows us, based on the user preferences, to suggest album playlists that are that fit into what the user actually is looking for. Right. So we've already talked a lot about vectors and vector embeddings, and we learned about the superpowers of vector embeddings. Now let's look at how to efficiently generate those vector embeddings. And for that, I'll walk you through some key features of Amazon Bedrock. What is Amazon Bedrock? Amazon Bedrock is the easiest way to build and scale generative AI applications with foundation models. And the foundation model is simply a very large language model that is trained by a vast amount of data. Right? And Bedrock provides a choice of leading models. And all of those models can be accessed via a single API. And Bedrock is also a managed service, so there's no need to create any infrastructure or take care of scaling, patching, security updates, and so forth. That is all being taken care for you in the service. And it comes with enterprise-grade security and privacy built in. So that means primarily we don't train that model, those models with your data, and we're also not sharing that data with anybody else. And of course, you can use those models as is, but you can also customize the models and do some fine-tuning or pre-training the models with your own data to provide a better context. So here, in that slide here, we see the models that we are providing in Bedrock. And when we started with Bedrock, we had a lot less models available. but we are adding new models basically as we speak. So here you see 29 models on the slide from 7 different providers, and these are leading providers from AI21 Labs, for example, Mistral, Anthropic, Cohere, and they all provide different capabilities in those models and different sizes. Right? And in fact, just last week, we have announced a new capability in Bedrock that allows you to import your custom models as well. And having that broad choice of models is really important. That's the kind of feedback we're getting from the customers. For every use case you're building, every model provides a different value. Right? So you need, in your development experience, you need to have a choice of different models for using different capabilities and building different things, basically. Right? So let's look a little bit more detailed into the Amazon Titan models. And Amazon Titan models are created and pre-trained by AWS. And that gives us a couple of benefits that we are providing to the customer. First, we have some expertise in using machine learning and generative AI technology within Amazon. We have a track record of 25 years doing that, and not only creating the models, but also deploying and make them available at scale. And the learnings we took the last couple of years with that is basically got into the development of Amazon Bedrock and allows us to offer a service like Bedrock. Second, we can provide a range of models that offer powerful capabilities to great economics to support a variety of use cases. Right? And when we look at the Titan models, we see here 3 categories of models, basically. First, it's models that can generate text. And here we see 2 models. We just have announced a 3rd model last week, so we're adding new capabilities to Titan as well. The second category is models to generate images, and the 3rd category is the vector embedding models that do exactly what we just talked about, generate embeddings for your text, or with a multimodal model, we generate embeddings for text or images. And that also works for different spoken languages. So let's have a closer look at the Titan multimodal foundation model here. Right? So this model can convert images and text into vector embeddings, and you can also use it for search use cases to search for text, to search for images, or to search for combinations of text and images. And with that model, we also support 25 spoken languages, so it's an ideal choice for building these multilingual use cases containing different languages. And of course, you can customize that model as well, do some fine-tuning, add your own data to it. So with that, let's have a look at SAP HANA Cloud. Matthias.
Thank you, Markus. Hi everyone. In the next minutes, I'm going to introduce you to another key component in the generative AI architectures. Maybe before I talk about vector databases and HANA Cloud in particular, I would just like to get to know this audience like a little bit better. So maybe raise your hands. Who of you is using SAP products at the company? Oh, that's many. Thank you for securing my job. You're doing great. Maybe second thing, who of you is already familiar with HANA Cloud as a database? Oh, that's quite, I think we can skip my part. Abram, you want, okay. I didn't expect that. So then maybe a last question. Have you already worked with vector databases in general, not only HANA Cloud? Oh, even that. Great. So let me know if I'm talking something wrong, you just correct me, right? Okay. I hope it's going to be interesting for you anyways. So let's start with the very basics, what SAP HANA Cloud is. SAP HANA Cloud is SAP's managed cloud multi-tier database offering. It runs on an in-memory first architecture with a column-oriented storage as a primary persistence, and that makes it especially suitable for combining advanced analytics with live transaction data in real time. SAP HANA Cloud supports a variety of data models beyond the pure relational model. And comes with the enterprise qualities that our customers would expect, which is seamless integration of enterprise data sources, data tiering, scalability, and compression for optimized TCO, advanced high availability and disaster recovery paired with enterprise-grade data security and privacy, and all fully managed by SAP. Customers may connect their SAP or non-SAP data sources either via replication or trusted virtual access. And inside SAP HANA, data gets staged according to its relevance. So data that's queried more often is kept in memory, whereas data which is queried less often is either pushed to the native storage extension on disk or to the more cost-effective data lake, which is fully integrated into HANA Cloud. When consuming that data, again, the different applications like SAP applications, SAP Analytics Cloud, DataSphere, the business applications, but also custom or third-party applications can connect to the database and make use of the data and make use of the logic that has been implemented within the database. So you may be asking yourself, why am I here with AWS? The reason for that is simple. SAP and AWS have a long-standing technology partnership. And with HANA Cloud, we do make use of AWS technology. So over the recent years, we have made SAP HANA Cloud available on AWS data centers globally. And even more importantly, we enabled HANA Cloud to leverage the benefits of ARM-based Graviton processors, which result in optimized TCO and improved performance for our customers. So after the general introduction, let's go to my favorite topic, which is the HANA Cloud multi-model engines. This is now where it gets a little bit confusing because you heard Marcus talking about Amazon Titan and the multimodal embeddings, and this is now SAP HANA Cloud and the multi-model engines, which is a very similar name for a very different concept. So when we're talking about multi-model in the context of databases, we're talking about the fact that a database is able to handle more than just a relational data model. So for SAP HANA Cloud, there is the relational store, of course, but also the semi-structured document store, as well as remote data sources as persistence models. And on top of these persistence models, we have abstract data models for machine learning, enterprise search, the graph engine, spatial engine, and the vector engine, which I'm going to talk about later. So these abstract models make use of persistency and add special semantics to the data, like spatial interprets coordinates, graph interprets network data. All these different data models, they're seamlessly blended on the SQL and SQL script level. So this is how you eventually access that. This means in SAP HANA Cloud, the main interface to act with these different engines is, in fact, SQL. That benefit of the unification on the SQL level, it becomes a bit more clearer when looking at the key features of the multi-model engines and the personas that actually make use of it. So the spatial engine comes with spatial data types and reference systems, spatial functions, predicates, advanced algorithms like, for example, spatial clustering. And also, the spatial engine has an integration into business domain clients like Azure's ArcGIS or QGIS. The graph engine provides an abstract data model for network data, and it supports pattern matching queries as well as built-in algorithms to implement custom logic with a language called GraphScript. Additionally, relational data can be blended with semi-structured data from the JSON document store, and details of the vector engine I will tell you in a minute. And when using those engines to actually implement complex business logic right inside the database, it gets very easy to consistently provide that logic to the different personas in the company, as compared if you do it on the application level. Because if you think of spatial analytics, of course, there are applications doing that, but it gets very hard to share that across departments. And when that logic is actually built on the database, the developer can access it and use the algorithms and the data models via his SQL client. And the data scientist can use the same business logic for machine learning models in his Python environment, because we do have a Python integration. And the business applications, again, do also have access to the same data and can consume it their own way. And of course, their domain-specific clients. So let's deep dive on the engine that is most commonly used in generative AI scenarios, the newly introduced HANA Vector Engine. What the HANA Cloud Vector Engine delivers in its core is a native data type for high-dimensional vector data and functions to measure the distance between those vectors. So it's really these two things. This caters the most common query scenario, a top K vector similarity search. So the most common query is really to look at the top 5 or top 10 vectors which are close to another vector. I can show you examples how that looks on a SQL level. So on a DDL side, when you're defining a table which should keep vectors, you now have a data type which is called real vector, and you give a dimension constraint. So if you're looking at current embedding models, the dimensionality can be anything between a couple of hundred dimensions and up to 2,000. I think that's what's currently used. Once you created such a table, you can also manipulate it and, of course, insert vectors. There's some conversion functions where you can simply take a textual representation of the vector, you can transform it to the internal binary format and insert into the table. And then last but not least, the most common query scenario, the similarity search, now nicely embeds into SQL. So this almost looks like regular SQL. Select top 10 text from table 1 with an order by clause. And now the only thing where there's vector-specific functionality is that in that order by clause, you can use a distance measure, like in that case, the cosine similarity of that vector in the table to a reference vector, which you give here. Instead of cosine similarity, you can have the same scenario also with the L2 distance, which is nothing else than the Euclidean distance. So these functionalities that you see here, it's all plain SQL, so they can be consumed by any SQL client. So any application making use of SQL can simply consume the new vector engine. We have also developed a dedicated integration into our HANA Python client for machine learning so that data scientists can make use of it. Now, when you would like to consume vector-based similarity search from an applications developer's perspective, you may want to use development frameworks rather than having pure SQL access. So the two main frameworks that we support are here on that slide, which is the SAP Cloud Application Programming Model, CAP, and the LangChain framework. So CAP is the most popular framework for building enterprise-grade services and applications within the SAP ecosystem. That means using that framework and get the vector through the different layers, you can actually develop applications within the SAP ecosystem. Whereas on the other hand side, if you have LangChain, that's a framework that's well known to developers of applications that make use of large language models. So LangChain itself comes with a Python and with a JavaScript flavor, and both do support SAP HANA Cloud. Okay. So far, we've seen Amazon Bedrock to integrate large language models. We've seen Amazon Titan to create multimodal embeddings, and we've seen HANA Cloud to manage your business data and generate insights from those vector embeddings. Now, let's bring it all together in one common usage pattern. Typical usage patterns for vector databases are, for example, clustering. So based on the distribution in the vector space of the embeddings, clustering techniques may be applied to detect topic clusters. You can also use it to do anomaly detection. So once you have those topic clusters, you can look at vectors which are outside the clusters and which may indicate that there's an anomaly. You can have classification scenarios by measuring distance to reference vectors, or similar to what Markus has shown before with the Amazon Music recommendations, you could build a recommendation engine using vector embeddings. But by far the most widely adopted use case is semantic or similarity search. So a vector similarity search can be used to find similar images, to do semantic search on documents, and the latter is used in a pattern which is called retrieval augmented generation, or RAG for short. And that often gets applied in the context of applications which are based on large language models. Retrieval augmented generation addresses three issues that may occur when using large language models. So first one is each large language model has a certain cutoff date for its knowledge base. So depending on the cutoff date, the large language model is not able to know anything which happened after that date. Second one, large language models tend to hallucinate. So they can give answers which are factually incorrect if they don't know the right answer. And third thing, it's of course only trained on public data. So it means it doesn't know your company data. It doesn't know your sensitive data. That's probably a good thing in the first place. But on the other hand side, for some scenarios, if you're able to securely feed your company data into the model, it may be advantages. It may have advantages because you can provide more information to your employees. Okay. You can see an example here on the right-hand side. So I asked the large language model since which quarter does SAP HANA support a native vector data type for doing similarity search? And it answered totally confident since 2015, specifically the Q1 release, which is total hallucination. So it's factually incorrect. And now what can we do about that? Of course, we can change the model. We can use another model. We can also tune the model differently. In best case, the model says, I don't know. So simply, it is aware of the fact that it doesn't know the date. But here's where retrieval augmented generation becomes helpful. The idea of retrieval augmented generation is to look up relevant knowledge in a knowledge base and to actually add it as context to the actual prompt. So I have a second example where I've simply done that manually. So this time I said context. SAP released support for vector similarity search as part of SAP HANA Cloud on March 19th, 2024. And this time, with the same prompt, the answer was correct. SAP HANA has supported a native vector data type for doing vector similarity search since the first quarter of 2024. So the large language model understood the context, understood that it's relevant, and it extracted the information that I requested, which was especially the quarter and not the date. So it took March 19th, made the first quarter out of it. Now, the crucial question that you may have, if that's working, that's fine, but how do you do that at scale? So how do you find that context within your knowledge base? And how do you scale it if you have a large knowledge base? And this is now where I hand over to Abraham, who will give the answers to all of those questions. Thank you.
Thanks a lot, Matthias, for the great explanation about the power of SAP HANA Cloud. And we have seen a lot of different components, a lot of different terminologies. Maybe the first question that we have is, okay, how do I use all this? Let's start with an example, industry-related example. Imagine that you have created an application that basically is bringing and collecting inquiries and questions from your customers about your products, services. And they are expecting, in order to get the best answer from your services, not only consistent responses, accurate responses, but also quick. They would like to have it in this order and also in this time. Nevertheless, your customer service is basically receiving all these different questions, and they are not able to cope with that. And what is happening is that the consistency and the accuracy, it's being impacted. Therefore, the first thing you say is, well, why don't you use generative AI and the large language models basically to answer my customer questions? This will be a great idea. Nevertheless, it has a small caveat. All these different large language models may not have the specific information from your business. And this is the key challenge that you will face when you're looking into these new gen applications. If we look into this overall text generation workflow, we can see that the idea is basically fairly simple. Our user is going to generate an input. It's going to generate a question. And basically, this is going to be the prompt that is going to be sent to our large language model. And this is basically the overall process that he will need to have in order to start generating some responses. Nevertheless, as we already understood, this is not going to be sufficient. Therefore, today, we want to bring you another approach based on what Matthias already mentioned, that is called retrieval augmented generation, that is going to give you a way how to bring your specific custom data into life. So for that, we have created this specific data ingestion workflow, as we call it. And what it means and what we are trying to achieve here is basically that we are first defining our data sources. This is where our data, our custom data, is stored. Basically, these are going to be product documentation, application information, troubleshooting information, and so on. This is basically your custom proprietary information. Later on, you are going to split those documents into smaller portions that is going to be called document chunks. This can be done by different tools, including LangChain, that has been also explained by Marcus. And what we are trying to do here is to reduce the amount of, and optimize the processing of these documents, reducing and creating smaller portions of it. After we have created those smaller portions, we are going to use our embedding models. This is a different type of the large language models. As already Marcus also explained, the embedding models basically are going to generate numbers out of this text. And this is the powerful idea behind all this. Why? Because the embedding models are going to start generating for each of these document chunks a vectorized representation of your data that contains the semantic. And maybe if those terms that I just mentioned, it does not really ring a bell, what that means is that all these numerical representations, it's going to keep the meaning of what you basically are creating here, or your data is stored in there. And this is the power of the SAP HANA Cloud Vector Engine. Sorry, I think we need this one. OK, so now we have our SAP HANA Cloud Vector Engine, which is going to be fed up with all these different embeddings and chunks. So what we are storing here are the numerical representation of the data and these portions of data. Perfect. So now we have all these two elements combined into our database. Now what we do, how we can enhance basically our overall search process. If I click the right button, then we can see that we are adding a new flow. This is the extended path that we are going to add in the so-called retrieval augmented generation process. And the thing is pretty simple again. So this user input is also going to be sent to something called embedding model, as we already see here. So the embedding model is going to generate now a vectorized representation that contains the semantic of our user query. Basically, what this means is that all this input that the customer gave us, or the question, is going to be transformed in numbers, in a vectorized representation that will be able, or that can be used later on to be compared, to be used within our SAP HANA Cloud Vector Engine as an input in order to do comparisons against the other embeddings that were already stored from our custom data. What this is going to give us is a similarity search based on the overall context of our data. And what we are getting here is that the user input, it's able now to give us relevant context. Because now we are looking for information related to the question of our customer, but that is coming from our custom data that we just store in our SAP HANA Cloud Vector Engine. Now we have generated a new context. Basically, these are portions of your documents. Those are the document chunks that you just stored before. And those document chunks could be product information, a snippet of your user manual, troubleshooting information. And what you're going to do with that is to merge it or to bring it together with your user input in order to create the augmented prompt. I'm really having fun with this. So the augmented prompt is basically the mix of these two sections here. Not only the user query, but the additional context, your custom business context that only you have access to. Now the large language model safely can access this data and provide a specific response dedicated to your customers. For example, if a customer now asks, hey, I would like to know how to do a factory reset of my device. This is the model and the year. He will know exactly in your business context what he's referring to, and he will give a list of detailed instructions on how to proceed with it. Therefore, you can already see the power of the different combination of our solutions from SAP and AWS in order to create these new generation applications. that are going to enhance not only your business, but it's going to reduce the support cost and improve your operational efficiency. At the same time, improving your customer satisfaction, which at the end is basically your main goal. That's awesome. And we have been really aware of all the power of the LLM models, the large language models. All of them works basically with text. But in this new world that we are living, only text is a little bit limited. And we are also interested in to understand how we can get information, not only from text, but images, and maybe other type of content. So for that reason, we have created something called multimodal models. Multimodal means that we are not referring only for one type of input data, but we are mixing up not only text, but also images. Let's come up with another example. Imagine that you're working in a production line, and one of your employees or yourself would like to understand how to use this device, as myself right now, having just so much struggle. Then you just take your mobile phone and you just scan this specific component. And what will you receive is information specifically dedicated on how to use this component within your production line, with not only images, but related text that it is based on the context of your business. This is information that only you have, nobody else. This is a really powerful approach to solve different problems. And in order to do that, we have also come up with another workflow. In this case, pretty similar to the previous one. Now we are combining not only text, but a multimodal setup of images and text that are going to be input, or are going to be the input to our embedding models. But these are not going to be the normal embedding models, as we discussed before, but these are going to be the multimodal embedding models. Okay? So we are adding more words just to explain that this embeddings model is going to generate a vectorized representation on numbers out of text and images. And you will keep the overall context of it. So the overall meaning of what those images means within your business. After that, we are going to store all this data into our SAP HANA Cloud Vector Engine, which is going to allow us, it's going to be our unit, to do all these powerful similarity searches across all the different data. Now, the next step is how to use that, how we are going to search on that. We are going back to the same input. We are now receiving text, images, or a multimodal combination of text and images, which are going to be used not by our multimodal embedding batch API as before, but this is going to be our Amazon Titan multimodal embedding real-time API. What we are going to do with this is to generate, again, a vectorized representation that keeps the semantic of the user input, and thanks to the overall algorithms, especially the key nearest neighbor algorithm that has our SAP HANA Cloud Vector Engine, we can bring from one of the user input search the most relevant embeddings, or the most relevant portion of text and images that are related to our user query. That's going to be the overall result that we are giving to them, a combination of text and images as a result. As you can see, these powerful capabilities from AWS and SAP combined, bringing not only normal large language models, but also embedding models. It's giving us the capability to go beyond the standard development applications that we have until now developed. So let's jump a little bit into what we have learned over these 45 minutes. The first thing that we would like to highlight is that vector embeddings are only a numerical representation of data that contains the semantic of that data. That's it. So we are going to use those mathematical representations to do comparisons, to do mathematical checks, because it's easier to use mathematics and numbers to compare between each other rather than words. And that's where our SAP HANA Cloud Vector Engine comes into play, because this is a powerful computation engine that is going to do all these similarity semantic searches for us. We don't have, this is transparent for us. We don't have to care how it is doing it, but he's going to return the best solution for us. As a complement to that, we have Amazon Bedrock, which is AWS foundation model service. And it is not offering all these different large language models and overall multimodal models, but also it's bringing us the embedding models and the multimodal embedding models into the play. Therefore, creating a layer of abstraction that it's going to make our life easier to work with all these different concepts. Therefore, the main message from our side to you today is, please go and build your next generation applications using all this technology. And before that, before you start coming up with all these new applications, please fill up the survey for this session. Thank you very much.